Kirkwood Math. All right, ladies and gentlemen, here we are. We are going 5.1, taking a look at absolute value functions. We are in page 98 and 99 of your student companion. Before we begin, we're going to talk a little bit about these vocabulary words. So vertex and the axis of symmetry. Vertex, if you've heard it before, is the point of a angle, right? It's like where the two lines meet. So for example, the vertex of this V shape would be right here. The axis of symmetry is if I have a graph of a shape like a V, like this one over here, where is the axis? Where's the line that's going to cut it in half so that one side is reflected perfectly across the other? So when we're dealing with these shapes, your axis of symmetry is always going to be that line that goes right through your vertex, okay? And we're, for the most part, going to be vertical, but whatever line goes through so that both halves are equal, that is your axis of symmetry. Okay, back to our problem for today. So we're going to start looking at absolute value functions and looking at the features of them and how to construct them and what they mean. It's going to be very similar to the absolute value equations, except we're actually graphing the information from those equations first, not just finding solutions. So this function right here, the function is the absolute value of x. If I want to look at what its graph is going to be, I'm going to go ahead and make a table. This table, you could call it a H chart. I like to call it that, if I can do this without getting too crazy, because it kind of looks like an H, although my H is super squiggly. Sorry about that. But basically, I'm going to make this chart where in the first part is going to be x, whatever value I want for x. Then is my equation or function. And then afterwards are my answers, my solutions. Okay, so here they just picked a bunch of points to represent x. Remember that x is also your domain. Sorry for the writing. I have to go slow or else it doesn't register. Let me write it again. X is your domain. Which means that f of x, the second part right here, is the same thing as your y, which is your range. So when we're talking about functions, you've got domain and range. Don't forget, you should be taking these notes in the gray section of your student companion, okay? I'm going to go ahead and get rid of this right now, though, so that you guys can see a little bit better. But we've got our domain and our range. So what they did was they took these numbers. They just picked their own numbers. They plugged them into the equation. The absolute value of -2 is +2. And then they wrote it as a ordered pair. If x is -2, then f of x is +2. And they did that with -1, 0, +1, and 2. What you'll notice here is that 0, 0 is the vertex. It's the turning point in our graph, okay? It's the part that where our graph comes down and then turns around and goes back the other way. The vertex is also known as the turning point. I can tell that from my numbers here because I have negatives, 0, and then I start going back up to positives. If I were to take these points and graph them, you can see that this is my absolute value function graph. It looks like a V. The reason it looks like a V is because with absolute value, you have both your positives and negatives. So it's going to have both of those values. Okay. The axis of symmetry is 0. X is 0. This is our axis of symmetry right here. If I can draw those lines. The graph has a vertex where it intersects. Okay. This is representing our minimum value, the smallest number in our graph. And it comes up with these two pieces here, left and right, which are reflections of each other. All right, give it a try. Go ahead and make your own little chart here. So I made an H chart over to the side, and tell me what's the domain and range of this function. Using this chart can help you. You don't have to make the chart, but if you're forgetting what domain and range are, the chart can help remind you that whatever value x is your domain, and whatever value your f of x or your y is your range. So you saw how to graph an absolute value function using the table to put input values and get output values. But the main part of this lesson is really just looking at these absolute value functions and comparing them, talking about them, seeing what they look like and what happens when we do different things. So in this case, we have two absolute value functions here. We have the red one, which is g of x, which equals 2 times the absolute value of x. And then we have the blue one, which is just the same one from last time, the absolute value of x. We're going to compare these two graphs and look at the differences. So you probably noticed that the blue graph is wider than the red graph. You've probably noticed, though, that they basically are the same graph. We've just changed the angle or the slope of the two lines that stick out here. The domain of f and the domain of g are all real numbers because as I go out, remember, all numbers are going to be touched here, all real numbers, negatives, positives. Because the absolute value expression produces only non-negative values, the range of f is anything, y is anything, well, let me get my pen back. Y is anything greater than or equal to 0, multiplying the absolute value of x by a positive factor. In this case, 2 yields non-negative outputs, so the range of g is also the same thing. Basically, it's showing that these inputs and outputs are the same because they're basically the same graph, they just have different angles. The domain and range of the function g are the same as those as function f. So now it says to use the slider to explore the domain and range for other functions that are in this format right here. So if I were to take the slider and pull it down to 1, you can see that now my graph of g and f are the same. If I make it even smaller, and let's say make it a half, you can see that the slope is now half the angle from before, and that it's making this wider graph. If I go the opposite direction and make it 3, as the thing I'm multiplying x by goes up, then my slope increases. It's almost as though this is the slope. Do you see a relationship, a connection between slope and this absolute value graph? Okay, all the way up to 5. So we can kind of make them go different ways. Okay. In this example, we are looking at the domain and range of these two graphs. So we have the graph of f, the same one, okay, equals the absolute value of x. And we have the graph of h, but in this case is a -1 in front, -1 multiplier. That turns my absolute value function upside down. Okay, so you would think that these are almost a mirror image with an axis. If these were a reflection of each other, it would be going in this direction here, right? They're almost mirror images this way. Here we've got our positives and here we've got our negatives. The range of f has to be greater than 0 because it's above the 0, okay, my y value. But the range of h has to be less than 0 because we're going down. The domain of h and f are the same because our x's are going the same direction, right? So remember, our x's are our domain. And our y's are our range. So when we are looking at a graph, you can look at almost if I'm looking at my y values up and down versus my x values. Do they ever stop? Do they keep going? Things like that. Again, we can use the slider to kind of explore the two things. So if I make this negative into a even more negative into a smaller number, I'm going to get a skinnier upside down. If I make it 0, it becomes completely flat. So you can kind of play around with that. So if the multiplier in front of the absolute value is negative, you're going to have an upside down V. If the multiplier in front of the absolute value is positive, then you'll have a right side up V. All right, so now it's your turn. You're going to take these functions right here and compare them with that basic function that we did before. You can graph these in order to get your answer, or make that H chart and actually find your domain values and your range values and try to see what's the difference between G and F, and what's the difference between H and F. In these next few examples, we are interpreting what's going on here in these word problems and kind of like, why do we have functions that are like this? So in this first one, we have Jay rides a boat from his home to his friend's home in a neighboring state. The graph of the function dt is equal to 30 times the absolute value of t minus 1.5 shows the distance of the boat in miles from the state line at t hours. Assuming the graph shows his entire trip, we're going to answer some questions. So what this is showing me is that at 0 hours, when he starts off, he is 45 minutes away from the state line right here between Arizona and Utah. Okay. As he drives, he's getting closer and closer and closer. At an hour and a half, he is right here at the state line. Then, because he's continuing to drive north, he's going to pass and start getting farther away from the state line. That's what that graph is showing me. Okay, so that's what this explains right here. The first question says, how far does he travel? So if this is his whole visit, he traveled from 45 to 0 and then back to 45. So from wherever he was to the state line was 45 miles. And then wherever he ended was another 45 miles. That means that we are going 90 miles. He traveled 90 miles in 3 hours to visit his friend. This next question asks, how does the graph relate to the domain and range of the function? So remember, our domain is our x value. That's our time. And our range is our y value, which is our distance. Domain and range. Okay, so if we look at our solution here, since Jay's entire trip is 3 hours, the domain would be anywhere from 0 to 3, okay, because that's his time. He went from 0 to 3. He can't go farther because this is a word problem. These don't have arrows at the end. They're not continuing, they are finite. For range, we're looking at its distance. He only went 45 miles away from the state line. So the maximum he went was 45 miles away in either direction, and the minimum was 0. He was on the state line. So his range there would be between 0 and 45. So again, a lot of what we're doing is looking at these graphs and kind of analyzing them, what's going on. So try it on your own. Here's a graph about a cyclist. Can you figure out what's going on with this graph? Okay, now what we're doing is we're taking that same problem about Jay's boat, but we're going to look at a specific range. We're going to look at the rate of change between 2 and 2.5. Okay, that's in time, because I had the t here for time. So the slope, we want to find the slope between these parts right here. So between T2 and T2.5, we want to use the slope formula to find that slope. Okay, so you can see here they showed you that we're just looking at this segment of this graph. You're going to use that slope formula like you're used to, find the slope. And that tells me that during this point of his travels, Jay traveled 30 miles per hour. Now try it yourself. Can you figure out the rate of change from 6 seconds to 8 seconds of kata? Okay. And that's all we need to know about absolute value functions. So here are the concept summary if you want to pause and take some notes. But basically the graph of an absolute value section has a vertex, which is either its minimum or maximum if it's flipped the other way, value. The axes of symmetry is where it intersects the vertex and divides the graph into 2 sections that are reflections of each other. This is what an absolute value function looks like. And this is the graph of one. You can see the vertex here. This would be our axis of symmetry. And we're going to do a lot of talking about our graphs. and comparing them.